Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is lecture number 43 of Physics 5054 of GCSE. We were discussing in the previous lectures the concept of pressure, and now we are going to utilize the knowledge we have gained in the previous lectures. In yesterday's lecture, we did the MCQs, multiple choice questions. Today, we are going to discuss the structured question, and let us start it now. The first question is saying in A part, define pressure, state its SI unit. Ladies and gentlemen, at the beginning of this chapter, we defined the pressure, but for your memory refreshment, I wrote it again. Force per unit area is called pressure, and the mathematical form of pressure is P is equal to F divided by A, where F is the force and A is the area. Now the SI unit for pressure is Pascal. We have discussed that as well. Now let us turn our focus to part B of question number 1. B part is saying a rectangular glass block of dimension 30 centimeter, that is a rectangular glass block where this is the height, this is the length, and this is the breadth. So they given the data as length is equal to L 30 centimeter, but we will require the data in meter. So we have to convert this 30 centimeter to 0.3 meter. We have to divide it by 100. Breadth is given to you 10 centimeters, so we have converted it and it is 0.10 meter. Now the thickness is, or that height is 5 centimeter. When we divide this 5 centimeter by 100, we will get 0.05 meter. Weight of this rectangular block is also given, and that is weight is equal to 37.5 Newton. Ladies and gentlemen, keep in mind that weight is also a force. So instead of this F, we can write W as well, which actually we will write when we are solving this question. Now what they actually want, what the least pressure this rectangular block is applying on the tabletop, and what is the greatest force which is applied by this pressure, not force, the pressure. The question is saying that calculate the least and greatest pressure it can exert when resting on a horizontal table. So first of all, we have to find the solution like this. We know that P is equal to F divided by A, and we are labeling it as equation 1 because we will refer to this part from another part of this question. We are having F as W, but we don't have this. Now, the least pressure will be at the top because there the depth is minimum, and high pressure will be at this. So first we have to find the area of least pressure, and that will be equal to length into breadth. Length with us is 0.30 and breadth with us is 0.10 meter. When we multiply it, we will get 0.03 0.03 meter square because it is area, so we will get it in the. Now P is equal to W divided by A, and where W is given as 37.5 Newton, and we found the area 0.03, and when we divide 37.5 by 0.03, we will get 1250 Pascal. 1250 Pascal. That will be the least pressure exerted on the top of the table by the rectangular. Area of greatest uh, pressure. So it will be at the bottom. So we have to find that as the length and breadth into height is equal to breadth into height. Breadth is given as 0.10 meter, and height again we are using 0.05, and that will be meter square. So when we calculate this area and multiply it, it will be 0.005, 0.005 meter square. Now we have to put this value in the equation W divided by A, where W is given as 37.5 and area we found 0.05. When we divide 37.5 by 0.005, then we are getting it is 7,500 Pascal. So in this question, in the first part, they are asking what is pressure, and we use this formula, and we also use this unit. In the same question, they wanting us to use this formula which we used here, and also this Pascal we are using here. Okay, now we are turning our uh, we are turning our focus to question number 2. There is a diagram given in question number 2, and they are saying the diagram shows a simple mercury barometer used to measure the standard atmospheric pressure. Between X and Y there is a vacuum. Between there is an empty space given. You can see that Let me draw it for your understanding. Please wait for 1 second. Okay, this is the figure given to you in the book, and there are empty spaces in the form of A, B, C. Okay, let us now understand the question. The diagram shows a simple mercury barometer used to measure the standard atmospheric pressure. Keeping in mind this situation, we have to answer. The first A part is saying between X and Y there is a dash. Between X and Y there is a vacuum. There is a vacuum. So, yes, we know that above the mercury column there is a vacuum. So, in the first part, you have to write this. The B part is saying draw on the same diagram a point Z such that barometer reading between point Z and point dash point Z and point dash measure the atmospheric pressure. So we have to draw, this will be a point Z and this will be between Z. So you have to write X here. Between Z and X there will be atmospheric pressure. They are saying that draw a point which will tell you that between Z and dash, they given us 2 point X or Y, but tell Y it is not. From here till 76 centimeter of Hg will be the pressure. So in the second there is X. Now let us draw our focus towards the C, and that is discuss the effects, if any, of using a wider tube on the thermometer and the barometer reading. If we are using a wider, for example, we are using a tube like this. This is a small diameter of this tube and that is a large diameter of this tube. So the question is asking that whether they will put any effect on the reading of the barometer, any effect on the barometer. Let us do this by means of mathematical calculation and then we will derive the conclusion. As we know that F is equal to M cross G, we should write it M G. This is equation number 1, and we know that density is equal to mass per unit volume. Now mass is equal to density into volume. Put equation 2 in 1, we will get F is equal to density into volume into uh, volume into G. Now we can write further this as F, this is density, and volume of this three-dimensional shape is uh, height into area, base area. This is the formula. Volume of a three-dimensional, volume of a cylinder, you can say that H multiplied by base area, and we will introduce this G on its place. We can write that if area is equal to rho into height into G, because we brought this area on this side. So force per unit area is pressure, and pressure is equal to rho h and G. Now, ladies and gentlemen, from this equation we can see that pressure only depend on the density of the liquid we are using in the barometer. The height also affect it, and the value of G. This is directly proportional, but it is independent of the diameter. There is no mention of diameter inside this formula. So, no, it will not affect the barometer reading if the area is wider. It is negligible. Remember that the area, the diameter should be about 100 centimeter for the barometer. Millimeter. 100 millimeter is used in the barometer, so it will not affect. The question is saying describe the effect, if any, of using a wider tube on the barometer reading. No, it will not affect. Number D, describe what would you expect if a little alcohol is introduced in the region between X and Y. We are, the question is saying that if in D part there is a small droplet of alcohol is introduced in this vacuum, what you will expect. Ladies and gentlemen, when we introduce a small droplet, not a big amount, when we are introducing a big amount, it will destroy the barometer, because pressure from outside, from inside then will be very much high, and from outside it will be very much low. So as a result they will explode. But if we are introducing a small droplet of alcohol inside the vacuum, then it will be evaporated and it will be converted to small droplets. Those droplets will put pressure on the column of mercury, and the column of mercury will come down, and the calibration of the barometer will totally be destroyed, and we will not be able then to take the correct value of the pressure, atmospheric pressure, yeah, any pressure we want to find, because it will destroy this calibration. This small droplet is changed alcohol into, just like you consider it, the drops of rain. Raindrops are bigger, but we are just giving you the example. So, ladies and gentlemen, when high they will apply pressure, they will strike with the wall of the tube, glass tube. So, when they are striking with the tube and pressure is high, then it means that it will destroy the glass tube. But if a small amount of alcohol, as it is said in the question, is introduced, then it means that a little evaporation will be there, and a small amount of pressure will also be applied at the top column of the mercury, and as a result the mercury column will come down, and we will never get, it will be less than 76 uh, millimeter of Hg. So it means that in this case we will not be able to take the correct value. Okay, now we are turning our focus to question number 3, which is on page number uh, which is on page number 112. Number A part is saying that describe with the aid of diagram how a mercury barometer is set up in a laboratory. Why is mercury used and not the water? Now, in this question, we did the first part, how to set up a mercury barometer. If you want to get more understanding of that, go to my previous lecture in which we discussed this concept in greater detail. But the second part is important. The second part is saying why is mercury used and not water? So let us discuss that why mercury is used inside this. Mercury is commonly used in barometers because of its high density. It is more compact. Density means that it will occupy less space. So high density, so the height of the column will be a reasonable size to that of atmospheric pressure. That is why we are using mercury, and why we are not using the negative I wrote in the red, but the positive answer I wrote in the blue. So high density, height of the column will be of reasonable size. If we are using water, then what will happen? Water is not used because of its low density. So that barometer using water would be 13.6 times taller, which is very big. If the mercury barometer is of this side, then the water barometer height will be more. Why this 13.6 times taller than Hg? Because density of water is 1000 kilogram per meter square, meter cube. The density of Hg is, so it means 13.6 times taller than Hg. So it means mercury barometer will be of reasonable size, while the mercury barometer, if we are using water inside it, it will be 13.6 times taller than that of the Hg. This is the one reason. The second reason is that why we are using Hg does not stick with the glass wall of the tube. If it is sticking with the tube, you will apply the pressure and there will be a viscosity, and due to that you won't be able to take the correct answer. On the other hand, while H2O sticks, yani water sticks to the glass tube. This is the second reason. The third reason is the expansion produced in Hg due to the pressure is uniform. If you are giving pressure, so it will uniformly be increased, while H2O is not uniform because it is sticking with the wall, so it will not be uniformly increases. It will be like this, increase will be like this, because this part will be sticked with the wall of the tube, and the middle portion not, so middle portion will go up, so it will not be uniform, and as a result you will not be able to get the correct answer. Okay, these are the three reasons of question number 3, part A. Now, B part is saying the atmospheric pressure above the surface of the sea is measured by a mercury barometer. If the reading is 75 centimeter, what is the atmospheric pressure in Pascal or Newton per meter square? Calculate also the pressure at a point 30 meter below the surface of the sea. Ladies and gentlemen, In this case, 1 atmospheric pressure is equal to 10 raised to the power Pascal. Yes, it is. 1 Pascal is 76 centimeter of Hg. So 75 Pascal, we will divide that 76 divide by 75, which will be equal to 1.0133. So pressure is equal to 1.0133 into, because 1 atmospheric pressure is equal to 10 raised to the power 5. So instead of this centimeter Hg, we are writing 10 raised to the power 5 Pascal. Okay, ladies and gentlemen, now we are turning our focus to the question number 4. In question number 4, the diagram below shows a mercury manometer connected to a large vessel containing some neon gas. Given that the atmospheric pressure is 760 millimeter of Hg, calculate the pressure of the neon gas. Okay, the given data to us, height h is equal to 20. It is given in the example. So you can see that h is equal to 20 centimeter, atmospheric pressure is equal to 760 centimeter of Hg, or 760 millimeter of Hg. Okay, pressure of neon is equal to atmospheric pressure plus pressure due to Hg column, and that is given as 76 plus 20 centimeter of Hg, which is equal to 96 centimeter of mercury. And when cent means 10, so 96 multiplied by 10 millimeter. In 1 centimeter there are 10 millimeters, so we are introducing 10 millimeter, so that will be equal to 960 millimeter of Hg. Yes, this is used for this particular purpose. The second part of this question number 4 is saying that name one other use of manometer. Manometer is used to measure the pressure of air. That is the most important use. Meteorologists are using this in the weather prediction as well. That is also the measurement of atmospheric pressure. But one very important other usage of barometer is that it is used to find the altitude of an area. They are finding the pressure, that this is the pressure, and then they are predicting that this area is at this altitude from the sea level. Okay, question number 5, which is the last one for today, and that is A part. A U-tube manometer can be used to measure the pressure of gas. Explain how this can be done and what is meant by the term excess pressure. Now we did how the uh, barometer is working, but there is a very important part. What is the excess pressure? So I wrote this excess pressure for you. Excess pressure means that pressure more than atmospheric pressure. So that means that whenever we are connecting a barometer to the gas supply, it means it is putting extra pressure on the surface of mercury column. So it means that extra pressure is called excess pressure. That was one. The B part is saying the diagram shows the use of a YouTube manometer to compare the densities of the two liquids. If H1 is equal to 10 centimeter and H2 is equal to 20 centimeter, you have to keep this in mind. Calculate the density of the oil given that the density of water is 1.0 gram per centimeter square. On one side of the manometer there is water and the other side there is a liquid, that is oil. The density of oil is given, and because they are in balance, so we are saying density of H2O GH1 and density of oil GH2, G and G will be cancelled. So density of oil divided by density of H2O multiplied by H1 divided by this H2. Putting the values, we will get 0.50 centimeter. That was the whole story. There is two questions are remaining. We will finish these two questions in tomorrow's lecture, and might be, if we are having time, then we will start the next chapter as well. So don't miss the next lecture. Be in contact. Thank you for watching. Allah Hafiz.